An uncontrolled hazardous waste spill is inherently unstable. Toxic vapors expand, wind directions shift, and invisible chemical threats migrate with total unpredictability. In these conditions, physical containment is impossible without a rigid administrative framework. You cannot simply send workers into the hazard. You have to overlay the environment with the strict procedural architecture mandated by OSHA Standard 1910.120. This begins with an educational barrier. Workers must complete 40 hours of initial HAZWOPER classroom training to understand the toxicology and the protective gear required for entry. That classroom theory is tested. Workers must complete exactly 3 days of supervised, hands-on field experience, practicing decontamination and running emergency response drills. But training is only half the baseline. OSHA also mandates a strict physiological requirement: medical surveillance. Workers must undergo a comprehensive medical examination to prove their bodies can withstand the chemical stress and physical toll of wearing heavy protective suits. Crucially, this medical clearance must occur before the initial training begins, not after. If a worker fails to clear that physiological baseline, they cannot safely wear the gear. If an operation skips these educational and medical prerequisites, the entire response is structurally compromised and legally non-compliant before a worker approaches the site. The burden of organizing this response falls on the incident commander. Their primary administrative responsibility is drafting the comprehensive work plan that will dictate every operational phase. The core of that plan is the Site-Specific Safety and Health Plan, or SSSHP. This is the defining legal blueprint that governs all hazard analysis and dictates exactly how workers will enter the hot zone safely. The SSSHP dictates core operational logistics, site characterization, geographic control, and exact decontamination procedures. It must also definitively identify atmospheric threats, specifically noting any conditions immediately dangerous to life and health. Because it serves as the ultimate set of rules for survival, a physical copy of the SSSHP must remain accessible at the worksite to all contractors, subcontractors, and government personnel at all times. The SSSHP provides the operational structure for the response. It functions as the logical framework that converts a chaotic site into a regulated workspace. With the blueprint drafted, operators must translate the theoretical hazards into hard data. They perform site characterization, a preliminary investigation to pinpoint specific inhalation and physical hazards before the general cleanup can begin. This diagram illustrates the rigid parameters required for safe oxygen content. Normal air rests at 20.9%. If the readings dip below 19.5%, the environment is legally classified as an oxygen-deficient atmosphere, and unprotected breathing becomes lethal. Beyond oxygen levels, responders use direct reading instruments to continuously test the air for combustible or explosive atmospheres that could be ignited by a spark. To measure toxicity, hardware like this multi-vision rapid detection instrument is deployed. These devices quantify the exact concentration of toxic gases in the air, determining immediately if the exposure exceeds OSHA's legal limits. If this initial characterization is insufficient or the data is missing, OSHA mandates a strict failsafe. Workers must default to Level B protection, entering the site equipped with a self-contained breathing apparatus. Continuous atmospheric characterization is the only way to convert an invisible, drifting chemical threat into actionable spatial data that allows site operators to proceed. That atmospheric data informs site control. This is the geographic implementation of the SSSHP, designed to physically partition the site and restrict contaminants from migrating into clean areas. This map shows site division. The highly contaminated footprint is the exclusion zone. Its boundary is the hotline, marked so no one crosses unprotected. Planners also factor in wind direction. Unprotected personnel operate from the support zone, placed strictly upwind from hazardous materials. Proper geographic zoning achieves one goal. It isolates the lethal reality of the exclusion zone from the unprotected personnel managing the logistics in the support zone. Between those two extremes sits the contamination reduction zone. This physical transition area acts as an airlock, bridging the hot and cold zones. Within this buffer area is the contamination reduction corridor. This is the specific, heavily regulated pathway where the decontamination sequence is executed. Decontamination involves either physically scraping and washing off the toxins or chemically attacking them using neutralizing solutions that actively break down the contaminant structure. The corridor is organized into distinct stations. At the very first station, heavily contaminated outer gear is physically washed and scrubbed down. The primary risk during this sequence is secondary skin exposure. If a worker touches the contaminated exterior of their suit with their inner gloves or bare hands during removal, the toxin passes directly to their skin. To prevent this, the sequence of removal is exact. Washed outer suits come off first, then respiratory equipment is removed. Finally, the inner gloves are discarded, followed immediately by thorough hand washing. This process is a rigid architectural sequence of peeling away contaminated layers to protect clean ones. Any deviation from the order invites fatal secondary exposure. Even with strict zoning and decontamination corridors in place, site conditions remain volatile. Moving from the initial assessment phase into active cleanup changes the hazard profile. For example, physically handling and moving contained waste, like these concentrated drums, introduces sudden spike risks not present during the initial survey. To manage these shifting conditions, operations utilize the Incident Command System. This hierarchical management structure continuously enforces the SSSHP in real time. Part of that enforcement is the mandatory buddy system. Workers are organized into observation pairs, operating in constant visual contact to actively monitor each other for heat stress, fatigue, or a critical failure of their protective gear. Simultaneously, safety officers collect periodic air monitoring data. This allows the incident commander to dynamically expand or contract the geographic boundaries of the exclusion zone as the operation progresses. Maintaining compliance requires a continuous cycle of pre-screening, atmospheric data collection, and geographic isolation. This dynamic system ensures the hazard remains trapped inside the hot zone.